11.7 is going to take us back to Pascal's triangles, which we used when we were doing combinations. And whether you realized it or not, Pascal's triangle is also a sequence. So 1, the next row is 1 and 1. The next row, so remember this is row 0, this is row 1. The next one, there's 1s on the outside, and then this inside term comes from adding 1 and 1 and the 1 on the outside, and that gives me row 2. I go down to the next one, I have 1, and then I'm going to add these 2 and these 2 to get 3, 3, and a 1 on the outside, and that gives me row 3. So really, you can generate Pascal's triangle anytime you would need it, because it's simply a matter of dropping those 1s down the outsides, and then you're going to add the diagonal terms in between, and so I have 4, 6, 4, and that becomes row 4. Now this has another use. We can use it for combinations, which we did a couple chapters ago. It's also going to come in handy for this unit. So, for example, if you just think for a minute about expanding p plus q to the 5th, that literally means p plus q times p plus q times p plus q times p plus q times p plus q. And if you were going to expand that, you would have to group it by 2's first, FOIL those, then you would have to do distributive property with trinomials, and then you would have to do distributive property again, and it would probably take you a half a sheet of paper. Pretty sure no one wants to do that. So there's a shortcut. This exponent right here tells you to go to row 5 of Pascal's triangle, and when you go to row 5 of Pascal's triangle, don't forget to start at row 0. You get the coefficients of that expansion. So what we're going to do is we are going to write those coefficients down, and we are going to write 1, 5, 10, 5, whoops, another 10, 1, 5, 10, 10, 5, 1. Notice I left quite a bit of space. Now, whatever sign is here, if it's plus, they're all positives. So I know there's a plus here, plus here, plus here, plus here, plus here. So now I'm going to go through and I'm going to drop in my variables, and something really, really cool happens. If you start with the first variable, this first term would always be p to the 5th, and the variables are going to go down p to the 3rd, p squared, p to the 1st, p to the 0. Then I'm going to go back and I'm going to take the second variable and I'm going to go up, starting with 0. Q to the 0, q to the 1st, q to the 2nd, q to the 3rd, q to the 4th, q to the 5th. I should never end up with a power higher than 5. But if you think about it, there are 1, 2, 3, 4, 5 p's and 5 q's that ultimately get multiplied together. So then you go ahead and you clean it up. And what happens, this is 1. So I have p to the 5th plus 5 p to the 4th q plus 10 p cubed q squared plus 10 p squared q cubed plus 5p q to the 4th plus q to the 5th. And that is a whole lot faster than doing it this way. So now that we've done one, let's just recap how to. 1. Exponent tells you which row to get your coefficients. Second step, write the coefficients with space between. Step 3, if it's positive, all positive. If it would happen to be a negative sign, it alternates plus minus, starting with positive. So then you know what signs go in. Step 4, take first term and do it in descending powers. Then take second term and ascending powers. And remember, you always start with 0 and you start with the exponent to go down. So let's look at another example. So here I'm talking about t to the 8th. So I'm looking at the 8th row. I happen to have a negative, so I'm going to alternate starting with positive. And I'll show you that in a minute. So here we go. We're going to write those coefficients, giving ourselves space between. So I'm going to go 1, 8, 28, 56, 70, 56, 28, 8, 1. Then my next step says take the first variable and descend it starting with the exponent. T to the 8th, t to the 7th, t to the 6th, t to the 5th, t to the 4th, t to the 3rd, t squared, t to the 1st, t to the 0. My signs, I should have done that. Start positive. That means this one right here is positive, negative, positive, negative, positive, negative, positive, negative, positive. Lots of kids make a mistake and don't start literally with the first term. Then I need to take my second term, which happens to be s, and I start at 0 and I go up. And then it's a matter of cleaning it up. I can drop the 1s, and so I have t to the 8th minus 8 t to the 7th s plus 28 t6 s squared minus 56 t5 s3 plus 70 t4 s4 minus 56 t cubed s5 plus 28 t squared s6 8 t s to the 7th plus s to the 8th. And that's all there is to it. But guaranteed, if you had to FOIL out 8 t minus s's, it would not be that quick. But there's always a catch. Oh, little review here before we go on to the catch. Review our factorials. Remember, this is 6 times 5. I can stop at 4 factorial over 2 times 4 factorial. The 4's cancel. 2 goes into 6 3 times, and I'm left with 15. So quick little review problem. But let's go to a more complicated expansion. The key here is that this is one term, so you're going to have to use parentheses. So we are at row 4. Prior to this, we haven't had any coefficients, and this is where things are going to change a little bit for us. And again, the parentheses are everything. I had a negative, so that means I start positive, negative, positive, negative, positive. Now in this case, my first term is 3x. So I need to treat that 3x to the fourth. 3x cubed, 3x squared, 3x to the first, 3x to the 0. Now why is that so important? This 4 needs to get distributed, so my coefficients are going to change quite a bit. With y, I have y to the 0, y to the first, y to the second, y cubed, y to the fourth. So instead of just having those simple terms that I could combine and be done, now I have a little bit of algebra work to do in the fact that I have 3 to the fourth, x to the fourth, y to the 0 is 1, minus 4 times 3 cubed, x cubed, y, plus 6 times 3 squared, x squared, y squared, minus 4 times 3 times x times y cubed, plus y to the fourth. So what I've done is I have distributed, I've applied the power rule to those parentheses, and I have raised the entire thing to its appropriate power. So now I need to go through and do the resulting multiplications. So I have 3 to the fourth is 81 x to the fourth minus 4 times 27, which is 108 x to the third y, plus 6 times 9, 54 x squared y squared, minus 12 xy cubed, plus y to the fourth. Takes one more step, but is still significantly easier than doing it the long way. Now, to find the fourth term, you still really need to work it out. I'm still dealing with row 4, so I have my 1, 4, 6, 4, 1. If I'm after the fourth term, 1, 2, 3, 4, I'm after this term right here. So I really don't have to expand everything out, but I do have to do enough that I get the right terms. Again, be careful, single term, I have plus, so everything was plus. So this would be a to the fourth, a cubed, a squared, a. So I can shortcut that way a little bit if I'm comfortable. Then this term would be 3b0, 3b1, 3b2, 3b cubed. The only term I have to expand out is this one. So I have 4 times a times 3 cubed times b cubed. And so I have 4 times 27, which is 108 ab cubed. So it's a nice little shortcut to finding your terms. Just remember A1, A2, A3, A4, A5, so that you know exactly which one you are after. And that is the end of this entire unit.